Alright. When Einstein formulated his general theory of relativity to help us understand gravity, he found that gravity slows down time. This is a very interesting topic to me because this is used widely in GPS satellites. GPS satellites need to have precise timing in order to coordinate with the neighboring satellites. And because of this gravitational time dilation, they record time faster than we could than our wristwatches. As a quick intuition, if you were standing on Earth and you look at an object very, very far away, you would actually see that the time it calculates is faster than your own wristwatch. This is the gravitational time dilation. For a GPS satellite, gravitational time dilation has a very remarkable effect. Each day, each of the satellites accumulate an error of 38 microseconds. For something traveling as fast as those, it's an error of 10 kilometers every day. But with Einstein's correction, we can pinpoint you to the nearest few meters. I think this is important, the applications of physics. Physics has many worldly applications that we do not really, that we cannot understand. Physics is a subject that we don't really see in our day-to-day lives, happening all around us. For example, if general relativity and quantum mechanics wasn't formulated, we wouldn't have things like transistors or lasers. We wouldn't have nuclear power plants that power the lights that is currently blinding me. We wouldn't have things that are inexpendable for modern living. And to do this, physics today is at a standstill. One question: to unify physics to form one theory that could explain everything. The question that intrigues thousands of physicists today is to connect general relativity to quantum mechanics. To do this, they need to create one elegant equation to describe every phenomenon. Now this may seem like science fiction, but it is not. And we are closer to it than ever before. This is the starting point. Forces govern everything. Everything. From atoms to planets to galaxies to the structure of the universe. Everything is described by the forces. Forces govern everything. Now, what are the forces? Well, we know many forces from our lives, like forces from muscles, forces from jet engines, and forces from springs. But if we boil down all of these forces, they all come into four fundamental forces: strong force, weak force, electromagnetic force, and gravitational force. The forces have their own mathematics. There are equations that describe each of the four fundamental forces. But we do not know what happens when two or three of these forces interact. What happens when gravity interacts with the weak force in one system? We don't know. To do that, we need to merge the equations. And when we do, we get new equations that not only describe the particular forces, they describe what happens when the forces interact. Now, the interaction of the forces is what we're after. We have managed to merge three of the four fundamental forces, everything except gravity. And these are explained in quantum mechanics. I'll get to that later. For now, what are the four fundamental forces? Well, the first and the strongest, to explain this, I might need an atom. This is the atom. A nucleus of protons and neutrons being orbited by electrons. The nucleus is made of protons and neutrons, as I said, but protons and neutrons are not fundamental particles. They are further divided into quarks. There are three quarks in each protons and neutrons. The electrons are not quarks, they are leptons, another class of fundamental particles. And so there are particles that carry each of the four forces. These are called bosons, but the particles that carry the four fundamental forces that we are trying to understand are called gauge bosons. there are other bosons like the Higgs boson, which recently was a scientific marvel. Now, let's get into the four forces. The first and the strongest of the four forces is the strong force. Yeah. The strong force is basically the force that holds the nucleus as a ball. Remember, get this, the protons are positively charged and the neutrons are neutral. So shouldn't the nucleus break apart? It doesn't, because the strong force binds the protons to the neutrons with the help of bosons called gluons. Now, the strong force may be the strongest of the four fundamental forces, but it is not the force that governs large things like planets or the universe as a whole. Because the strong force, the effects of this force decay over large distances. So this force doesn't even affect us. We cannot see this force in action. But this is important for atoms to exist. The next force is the electromagnetic forces. The second strongest force, it is something that we do observe in thunder and lightning and electricity that is also blinding me. This force, unlike the strong force, can affect big things, and it is what gives charges to things. However, this force also doesn't affect the universe in a larger scale, because this force cannot accumulate. In other words, there are positively charged particles, but these are accompanied by negatively charged particles. And so they cancel each other out, and the effect also doesn't really have a wide scale effect. The bosons that carry this force is called photon, and yeah. The third strongest force is called the weak force. Wow. The effects of this force, like the strong force, the effects of this force also decay, but this force has other applications. Okay, let's understand beta decay, which is in black here. So this is called beta decay. It's in black, sorry. So, beta decay. Beta decay is a phenomenon that causes a neutron to break up into a proton, an electron, and an electron neutrino. The weak force causes this phenomenon, and this is extremely important for us to understand, because this is the phenomenon that happens in the sun. It powers the sun and in turn powers life on Earth. Without this force, nothing would be here, and we don't think of this force in our lives. Without this force, we wouldn't be here. We wouldn't be things. There wouldn't be things in this universe. The fourth strongest force, or rather the weakest force, is gravity. And ironically, this is the force that governs the universe. Gravity is not explained in quantum mechanics, it's explained in general relativity. So, yeah, we need to find that. In general relativity, gravity is the curvature of space-time. What is space-time? Space-time is space and time. Anyway, gravity is the curvature of space-time. In general relativity, time is essentially the fourth dimension. It can be considered to be another set of directions to the ones which we know. Forward, backward, left, right, up and down. Time is the fourth set of directions. In general relativity, time and space are not static things. They can distort, they can move. And the curvature of this, caused by mass or energy, is gravity. Now get this, gravity is not caused by the curvature of space-time. Gravity is the curvature of space-time. Now, we don't have a quantum theory for gravity, but bosons called gravitons are predicted to exist. Now, we've been studying the sun and gravity for a long time, and up till now we haven't found gravitons, so yeah, I'm questioning physics right now. Now let's look at monstrosity. That standard model equation that you see, it's okay. Let's explain this. So that's some of the things, and then some more. You know, the graduate student who typed this out, I feel a strong sympathy for. Yeah. Anyway, this equation describes everything from why the atom is a thing to why the sky is blue. This equation is the equation that merged the equations, the three of the four fundamental forces. This this equation, Einstein's field equation, this explains gravity. So you can see that is quantum mechanics and that is general relativity. So I know what subject I'm reading. And that is the starting point for what we are supposed to do. And it's scary. Anyway. Now, what will happen if you do find this elegant equation? Well, first of all, why do they call it the elegant equation? Is it on a t-shirt or something? That is not elegant. That is. String theory. This is the only chance that we have at combining these two equations. String theory is, to understand this, we need a violin metaphor. Now, in a violin, when you strum the strings, you get different notes, and when you hear two different notes at the same time, you get music, and you can identify the notes, right? So, in string theory, the strings of a violin are again replaced by things we call strings. That's where the name string theory comes from. Intricate. So, string theory is, in string theory, the strings are replaced by one-dimensional objects called strings, and these strings are essentially energy. Now, in string theory, different strings make different particles. Now get this, this is important. There are some of the strings that are present in string theory also make the bosons, the gauge bosons. So if we can understand the mechanics of the strings, we can understand the mechanics of the bosons, and therefore we'll know how the four fundamental forces work. Now, so by combining the two or three or four of the strings, we can understand all the interactions of the forces. What will we do with this grand equation? We can explain the Big Bang. The age-old question that has intrigued physicists worldwide. How did we start? How were we created? Why are we human beings? Well, because of the Big Bang. But what is the Big Bang? Physics cannot answer that, because the laws of physics break down at the Big Bang. Things get so chaotic that the laws of physics break down. The universe was extremely small, so quantum effects had a part in it. But it was that small because of gravity. It was that small because of gravity. I'll just leave you with that. So all the four forces had an effect, and we need to know how they interacted. And by creating the elegant equation, we can answer the Big Bang. Now, before I leave the stage, I would like you all to stand up. Thank you. Right. Do you like it? Everything, like standing up. Do you like the light that you see? Do you like gravity? Do you like it? Do you like the air that you breathe that helps you live, to survive? Well, why is it a thing? Why is gravity, light, the air? Why is it a thing? Do you feel like you need answers? Well, let's find them. For we are on the fringes of physics. Thank you.